when you have a definite integral from negative a to positive a, it has some kind of property which is quite useful for our integrations. Let me have some details. Now this one I can split into two integrals from negative a to 0 and right, plus from 0 to a f of x dx. Okay. Then I discuss this one. This one is from minus a to 0 f of x dx. I let x be, say, negative t. Okay, then the integral, it will becomes a f of a negative t, right? And negative dt. And when x is a negative a, then t is a, right? When x is 0, t is 0. Okay. Now then this one is equal to, I can use this negative to interchange the limit. So from 0 to a and f. This t and x is just dummy variable. I can write x, right? So dx negative x, f of a negative x dx from 0 to a. Then we replace this one back, therefore our integral from negative a to positive a f of x dx becomes this plus this, right? So from 0 to a, the limit is the same, and f of x plus f of a negative x. Oh, this is negative x, negative x, and dx. So that is a property when we have a definite integral from minus a to a, which becomes from 0 to a and f of x plus f of a negative x together dx. That is a property, okay? Now let me have two examples. Okay, the first example, this is the integral. This integral, well, it's not easy. You have rational, you have trig functions, you have exponential functions. Now, it's something special that it's from minus half pi to positive half pi, which satisfy our properties here from minus a to positive a, right? It can be done this way. It can be done from 0 to half pi, right? And f of x, which is the same thing as this one, e to the x plus 1 cosine x. Yeah. Plus f of a negative x, which is cosine negative x, positive x, no difference. So still x, cosine x. This is e to the negative x, right? Plus 1 and dx. Yeah, together. Okay, that's good. Now and then we have this from 0 to half pi, well, bracket. This is a cosine x e to the power of x plus 1. And this one we multiply by e to the x, numerator and denominator, right? So this becomes e to the x plus 1, right? E to the x times this one is this. E to the x times this one is 1. And this one is e to the x times cosine x. Yeah, dx. And this one is equal to from 0 to half pi. Here the denominator is the same, so we can add. And this plus this one, cosine is a common factor, right? Cosine is a common factor. And this one is 1 plus e to the x. Yeah. So this is nothing but a 1, right? So this one is 0 to half pi cosine x dx, which is equal to sine x, right? From 0 to... Yeah, that is equal to 1, sure. So this integral has been done very nicely with the property of this, you know. Okay, that's example 1. Now let's do example 2. This is the question. This integral is from 0 to pi, therefore it does not satisfy this property, right? So you must have from minus a to positive a, you know, kind of a symmetric. So we have to create, if possible, you know, this one. Well, how we do? Let me put this way. This is equal to let x be half pi minus t. Okay, we introduce t such that x is half pi minus t. Then this integral, when x is 0, t is a minus half pi, right? When x is a pi, and this t will be but when x is 0, t is a half pi. Okay. When x is a pi, this is a negative half pi, right? Yeah. Then this x will be half pi minus t. Sine half pi minus t is a cosine t, right? And this is a 1. This is a cosine half pi minus t is a sine. So this becomes sine square t. And dx is negative dt. Negative dt. Well, I hope everything is clear. And let me repeat again, okay? We let x be half pi minus t. Therefore, when x is 0, t is half pi. When x is a pi, t is a negative half pi. Okay, so x is replaced by half pi minus t. And the sine pi becomes cosine t. And the cosine square becomes sine square. Dx becomes negative dt. Now, this negative can switch the limit, right? This becomes minus half pi to positive half pi, right? So negative is gone. And this one is equal to, the t is just dummy variable. We can write for x, right? X. And cosine x. And 1 plus sine square x dx. Good. Very good. Now it satisfies this property, right? Because it's from minus half pi to positive half pi. So this one is equal to, according to the property, it becomes from 0 to half pi. And this is half pi minus x, well, cosine x, 1 plus, I have to be very careful because I always have some kind of absent-minded errors. So this is sine square x, okay, plus f of a negative x, right? Plus f of a negative x. So this is negative sine x after square is no difference. And when x is negative x, so this becomes half pi plus x, right? Cosine negative pi, cosine negative x is also cosine x, no difference, right? Then altogether dx. Very good. So this one is equal to from 0 to half pi. Now this is a common factor of 1 plus sine square x. Look at this one. A common factor, cosine x is a common factor. Left of half pi minus x, half pi plus x becomes pi, right? Cosine x. Yeah. Good. Yeah, this is good. Now, then this, I take pi out, the 0 to half pi, right? Now this is a 1 plus sine square x, right? Cosine x becomes the derivative of a sine x, right? Now this is for x. This is for x. Now this is a very nice formula for arctangent, right? So this one is arctangent sine x, from 0 to half pi. Yeah, this is a pi. Sine half pi is a 1. Arctangent 1 is a quarter pi, right? And the 0, 0 is a 0. So this one is equal to pi square over 4. That is the answer for this integral, which is a very nice application for this property, you know. So today I just want to show you 2 examples for the definite integral with this kind of property. Yeah, this example is very nice. Otherwise, it's not easy to integrate. Okay. Thank you for your watching.